Hello, Geometry Crew. All right, in day 3 of our SAT unit, we're going to talk about just factoring in general. Important skill at all levels of mathematics, also a very important skill for the SAT. So let's get started. We're just going to go over a few brief examples. So if we start with the first one, we have a standard trinomial here. So we're going to factor this trinomial. So supposing that this is factorable, this is going to be a binomial times a binomial. All right, and of course we went over many different methods. We probably went over 4 different methods of factoring, but the go-to that I'm going to be stressing in all of these is going to be guess and check. All right, so guess and check obviously relies on our understanding of multiplying binomials, the FOIL, and the factoring process. All right, so in terms of the FOILing process here, in order to get that r squared, that's this first term times that first term in each set of binomials here. So to get r squared, we would have r times r. Okay, if we take a look at this last part of each term, when we multiply those two, we need to get negative 45. Okay, but also to get that middle term, that's the result of adding the outer and inner parts of FOIL. All right, so we need two values that will multiply to get us negative 45. Now, there's always going to be a lot of different combinations because especially if we have a negative value, it's a negative times a positive. So negative 45 times 1 would give us negative 45. Positive 45 times negative 1 will give us negative 45. Now, if we look at some of the other factors of 45, we would have 15. So negative 15 times 3 would give us negative 45. Positive 15 times negative 3 would give us negative 45. And then we've still got one more set to go here. Negative 9 times 5 is negative 45. And then, of course, 9 times negative 5 is negative 45. We're looking for the set that adds up to be 4. All right, so when we scroll down this list, the pair that adds up to be positive 4 would be 9 and negative 5. All right, so we'd have positive 9 and negative 5 there, and we could double check that by using FOIL, by distributing those terms. All right, if we take a look at example 2, we just want to factor out the greatest common factor, and in general, that's always going to be our first step. All right, so for number 1, we recognize that, hey, this coefficient's 1, that lead coefficient, so the greatest common factor amongst all these terms is going to be 1. All right, in other examples, that might not be the case when we take a look at 3 and 4. So in 2, if we look at the common factors that these two terms have in common, obviously we can see m. So we could factor an m out, and what would be remaining would be m minus 8. M times m is m squared. Negative 8 times m is negative 8m. All right, so those are 2 basic examples so far. Now let's check out 3. This one's interesting because notice we can see that it starts and ends with an even number. So maybe you can, maybe the first thing that pops in your mind is that we could factor out a 2, but of course that middle term is odd, so 11, the only 2 factors there would be 1 and 11. That's a prime number. So first what we're going to do is create our binomials. Now, of course, in this example, there's different combinations for what we could have here. We could have x and 4x, and then we could, of course, have 2x and 2x. So guess and check is all about trial and error. So I'm going to do a couple of these wrong, hopefully. Okay. I'm just going to say, hey, let's say it's 2x and 2x. All right, so supposing that it's 2x times 2x, we also have many combinations for what we can multiply to get negative 20. All right, we got negative 20 in one. We've got 20 and negative 1. We got negative 10 and 2. Whoops, positive 10 and negative 2. We've got negative 5 and 4. And then positive 5 and negative 4. What we're trying to figure out is what combination would give us 11x. All right, so we could input some of these values. So for example, let me let me just plug in this one. All right, negative 10 and positive 2. All right, when we do the outer and inner parts of FOIL there, we'd get negative 20x plus 2x, which of course isn't going to be 11x. So that actually takes out this as a possible combo and that as a possible combo. Now, you can imagine plugging in negative 20 and 1 isn't going to help us anymore either, okay, because we're going to have 20x times either 20 or negative 20, and that's going to be a really big number, okay, and when we combine those outer and inner parts of FOIL, that's not going to give us 11x. So in terms of trial and error here, we got one more option. I'm just going to go back and erase these values here. Okay, and now let's try negative 5 and positive 4, for example. I'm not saying this is the most efficient process right now. I'm doing this intentionally wrong so that we can just get an understanding of what we're doing here. All right, so when we do the outer and inner parts of FOIL, the outer part would give us 8x, the inner part negative 10x. When we add those two up, we would get negative 2x. All right, so obviously that's not our option. So we just went through all the trial and error that we possibly could with 2x and 2x in there. So obviously that's not the answer. Let me erase what I've got here. So now that tells us that one is 4x and the other one's got to be x. That's how we get our 4x squared. And now we look at those possible combinations again. All right, if we use some of our mathematical understanding here, remember, okay, this middle term is positive 11x, and this last term is negative. Okay, so when we do the outer and inner parts of FOIL, all right, the outer and inner parts have to be a positive and a negative. Okay, and then when we combine these, we get a positive. So that positive value has to be a little bit bigger. So let's do some more trial and error, and let's just use negative 5 and 4 as an example. Okay, so let's just say we're going to plug in negative 5 right here and then positive 4 right here. Okay, that's going to give us a positive product that's bigger than the negative product. So that's one thing that we're looking for. And let's actually figure out what that is. So if we multiply 4 times 4x, that'll give us 16x. And then negative 5 times x would give us negative 5x. And hey, that does add up to be 11x. So this is the combo. This is the solution here. We have the quantity 4x minus 5 times the quantity x plus 4. All right, of course, we could use other methods other than just trial and error or guess and check, but that's the method, like I said, that I'm going to go with. All right, let's take a look at 4. All right, now in this, we can clearly see that there's a greatest common factor here. Okay, 10, 80, 108, they're all even. However, one thing that we can tell, though, is that it's not going to be 10. 10 is not going to be the greatest common factor because 108 isn't divisible by 10. All right, so other options would be 5, but once again, 108, that's not going to work. So we're gonna factor out a 2 from this quantity, and we're going to have 5r plus 54r plus 40 remaining. Okay, so now we've got to factor out this remaining. Supposing that it's factorable, okay, we want to factor that remaining expression. So that's going to be a binomial times a binomial. Now, just for another method here, we're gonna look at the magic numbers method that we talk about in our school. So 5 times 40. If you're not familiar with this method, it's just one way that we can find what goes inside here. All right, so obviously one's got to be 5r, the other one's got to be an r. Okay, but we could find two numbers that multiply to be 200 and add up to be 54. Okay, and you could use your calculator to do that for you. And if you do that, you're going to find that the two numbers that multiply to be 200 but add up to be 54, whoops, we got to scroll down here a little bit more. Is 4 and 50. All right, so then we take those two numbers, divide it by 5. We get 10 over 1 if we write it as a fraction, 4 over 5 if we write it as a fraction. Put the variable on bottom, go bottoms up, and we get what is in those factors. All right, not very mathematical there. I mean, we're using math, but not very mathematical, but that's another way that we can find what's inside. Now, it wouldn't have taken us very long if we used guess and check to actually find those expressions, find those binomials. All right, let's move on. Now solve by factoring. All right, so first we factor, then we solve. That's the whole deal here. All right, so x squared plus 11x plus 24 factors to be x plus 8 times x plus 3, and we can double check that using FOIL. And then from here, it's saying that this expression times that expression equals 0. All right, the only way to multiply two things to get 0 is if one of these things is 0. So we don't know which one it is, or it could be both, and it can be both. So we're going to set each one of these equal to 0, and then solve. If we subtract 8, we get negative 8. If we subtract 3, we get negative 3. So x can be negative 8, and it can be negative 3. All right, let's check out this next one. All right, once again, supposing this is factorable, it's going to be a binomial times a binomial. All right, we're going to definitely utilize that guess and check method here. 7's a prime number, so this is going to be pretty easy. That's got to be 7n times n. And then we're just looking through a couple different scenarios that would multiply to be 8. This last term times this last term has got to give us positive 8. So that could be 8 and 1, negative 8 and negative 1. It could be 2 and 4, or obviously 4 and 2, depending on where we put it. Now, notice I didn't write the negative values down, and that's because the sum of the outer and inner parts of FOIL is 30n. That's a positive. So it's got to multiply to be these two numbers have to multiply to be a positive, and they've also got to add up to be a positive. So we're only going to deal with the positives here. Now, we could go through some logic here. When we add up the outer and inner parts of FOIL, we have to get 30n. So one scenario that we wouldn't want to write down would be this. Okay, 8 times 7 is 56. So obviously there's no way that that sum would be 30. So that's one thing that would not work. All right, if we check out the one that does, that is 7n plus 2 times n plus 4. The outer parts would add up to be 28n, the inner parts 2n, and that would give us that 30n there. But wait, we're not done yet. We still got to set these factors equal to 0 and solve. So set 7n plus 2 equal to 0 and solve, and set n plus 4 equal to 0 and solve. In this one, we get negative 4. And we'd subtract 2 here and divide by 7, and we'd get negative 2 sevenths. All right, so negative 4 and negative 2 sevenths would be our two solutions there. All right, check out 7. All right, notice we have n squared minus n. This is very much like number 2. We just have to factor out the greatest common factor. All right, so the greatest common factor would be n, which would leave n minus 1 remaining. And then set each factor equal to 0, so we get n equals 0, and n minus 1 equals 0. And we solve this, and we get positive 1. All right, and for each one of these, of course, we should always double check our solutions. For 8, last one, this one looks a little bit different. That's because it's not in our standard form. Let's put it in that standard form. So we got to get everything over to one side. So subtract 15k first. I'm going to write it right there because that's where I'm going to put it. k squared minus 15k plus 56 equals 0. We want this thing in standard form. All right, then supposing that it's factorable, it's going to be a binomial times a binomial, and we can do some really easy guess and check here to figure out what this factors to be. So that the last two terms have to multiply to be 56, and the outer and inner products have to add up to be negative 15k. So one thing to think about is they multiply to be a positive and they add up to be a negative. The only way that's possible is that if both of them are negative. Okay, and of course we have different options, but notice when we add them up, we only get negative 15. So there's no point in writing like a negative 28 or negative 2, because when we add those together, we're not going to get negative 15. So that's how we get our solution, or sorry, our binomials, which is k minus 8 times k minus 7. Now set each one of these equal to 0 and solve, and we get 8 and 7. All right, folks, so that was our really, really brief factoring review in this SAT unit. If you have any questions, make sure to email me, and have a great day.